So good morning, students. Am I audible to you? Am I audible to you? Am I audible to you or not?
Yes, sir.
Then see, I'll start.
Hmm.
See here, in the last class, I have already started the consistency of a system of equation. Okay, consistency of a system of equation. Clear? Keep silent. Keep silent. Okay, see here. So when a system is said to be consistent, hello, a class lo isun. Okay, see here. See here, what is a consistent system of equation? So in the last class, I start what is the system consistency of a system of equation. Okay, so what it is? If the rank of the matrix is equal to the rank of the augmented matrix, then we can say that the system is consistent.
$45. Hmm?
Okay, see here. One sec. Okay, see here. So if rank of A equal to rank of C, clear? If rank of A equal to rank of C, then we can say that the system is consistent, clear? Which is equal to the number of unknowns. N means number of unknowns. Okay, see here, and where n equal to number of unknowns. So there are three here. This is a system of equation Ax equal to B, where A represents matrix. Keep silent. Ax equal to B. Okay, where Ax equal to B. I already admit all the students like this. See here. So Ax equal to B. Now we have to find out the rank of A and rank of C, where C is the augmented matrix. Now if rank of A equal to rank of C, then solution exists. And if rank of A not equal to the rank of C, then there is no solution. That means the system is inconsistent. Okay, now there is two parts. If rank of A equal to rank of C equal to N, N means the number of unknowns. Unknowns means that's X, Y, Z. Okay, then it has one unique solution. Okay, then it has one unique solution. So if it is not equal to n, that means less than to n, then the system has infinite number of solution. Clear? Now let's see one example. Let's see one example. See here. So what? So that the equations twice x plus 6y equal to minus 11 and 6x plus 20y equal to minus 6z equal to minus 3 and 6y minus 18z equal to minus 1. 6y minus 18z equal to minus 1 are not consistent. Okay, so when it is not consistent, if the rank of the matrix is not equal to the rank of the augmented matrix, okay, if the rank of the matrix is not equal to the rank of the augmented matrix, so this is the augmented matrix. C is to C equal to A is to B. See here, what is A? What is the coefficient of X? It is 2. So this one. Coefficient of Y is what? 6. It is this one, 6. Is there any Z? No. So the coefficient of Z will be what? 0. Is 2. This is the matrix B. Okay. So this is minus 11. Again, coefficient of X is 6. This one. Coefficient of Y is 20. This one. Coefficient of Z is what? Minus 6. Okay. And what is the constant here? It is minus 3. Same way, see the last equation. Is there any x? No. So coefficient of x will be what? 0. And the coefficient of y is what? Coefficient of y is what? 6. And coefficient of z is what? Minus 18. So which is to is to minus 1. Clear? So our aim is we have to make this equal to 0. We have to make this equal to 0. How we can make this? So see here, 6 minus 2 3s are 6. So it will be 0. So we simply do this one. Row 2 tends to row 2 minus 3 row 1. Row 2 minus 3 row 1. So see what you got. 6 minus 6. It will be 0. 20 minus 3 6 are 3 6 are 18. So it will be 2. Again minus 6 minus 0. It will be minus 6. Again minus 3 minus 3 into minus 11. That means minus 3 plus 33. So it will be 0. Clear? Next this one. Again from C here we have to make it to the echelon form. So see here now. 6 minus 3 2s are 6. So it will be 0. So we make this one. Row 3 tends to row 3 minus 3 row 2. Row 3 tends to row 3 minus 3 row 2. Okay. So 0 minus 0, which is equal to 0. 6 minus 3 2s are 6. Okay. 6 minus 3 2s are 6. 6 minus 6, which is equal to 0. Again minus 18 minus 3 into minus 6. That means minus 18 plus 18, which is equal to 0. Again minus 1 minus 90. So it will be minus 91. Now you see here, this is the matrix A. Okay. The matrix left hand side of these two is matrix A. Clear? So here how many non-zero rows are there? There is only 2 non-zero rows. So rank of the matrix A will be what? 2. And this is the whole matrix, whole augmented matrix. Okay, this is the whole augmented matrix C. C means what? A is to B. Now see here, how many non-zero rows are there? There are 3 non-zero rows. 1, 2, 3, because there is one non-zero element. Clear? That means this is the matrix A. This is the matrix A, where how many non-zero rows are there? 2 non-zero rows are there. So rank of A will be 2 and rank of C is what? It is 3, since 3 non-zero rows are there. Now from here what you got? Rank of C is 3 and the rank of A is what? 2, which are not equal. If these are not equal, then system is inconsistent. That means no solution is there. See here. See in this case, if rank of A not equal to rank of C, then the system has no solution and the system is what? Inconsistent. Okay, and the system is inconsistent. Next, see. So test the consistency and hence solve the following set of equations. So how many unknowns are there? 3 unknowns are there. What are the unknowns? X1, X2 and X3 are the 3 unknowns. Okay, now see, we can write this system of equation in the form Ax plus B, where A is the matrix contain the coefficient of x1, x2 and x3. See here, x1 coefficient of x1 is 1, coefficient of x2 is 2 and coefficient of x3 is what? 1. Similar way, we put the coefficient of x1, x2 and x3, and here it is x1, x2, x3 equal to, so this is the matrix contain the constant of this equation. So which are these? 2, 1, 3, 4. Okay, now see here, this can be written as Ax equal, this is the matrix A, this is the matrix X and this is the matrix B. Ax equal to B. Now what is the matrix C? C means, I already told you, A is to B. C means A is to B. So this is the matrix A. This one, 1, 2, 1. After that, 3, 1, minus 2, 4, 3, minus 3, minus 1, 2, 4, 2. Okay, this is the matrix A. And this is the matrix B, 2, 1, 3, 4. This one, 2, 1, 3, 4. This is the matrix B. That means it is the matrix A is to B. Clear? Now we have to find out the rank of the matrix. See here. So this is already 1. So this is already 1. So how we can make this element equal to 0? We can make it easily make it to 0. How? Row 3 tends, row 2 tends to row 2 minus 3 row 1. That means 3 minus 3, result will be equal to what? 0. Again, row 3 tends to row 3 minus 4 row 1, because 4 minus 4 into 1, it will be 0. And row 2 tends to row 2 minus, sorry, row 4 tends to row 4 minus 2 row 1. Okay, see here, we make this one. Row 2 tends to row 2 minus 3 row 1. Again, row 3 tends to row 3 minus 4 row 1. Row 4 tends to row 4 minus 2 row 1. Okay, so after calculating this, we got this one. Okay, row 4 minus 2 row 1, it will be all equal to 0, because 2 minus 2, it will be 0. 4 minus 2 into 2, that means 4 minus 4, which is also equal to 0. Again, 2 minus 2 into 1, that means 2 minus 2, which is also equal to 0. Again, 4 minus 2 into 2, that means 4 minus 4, which is also equal to 0. Clear? Now we have to check whether we can make this one equal to 0, because we have to make it to the triangular form. Remember, we have to make it to the triangular form. Okay, so that's why next our aim is we have to make these elements equal to 0. Okay, by using this one, we can make this equal to 0. See here how we can make. At first, we divide this row 2. Row 2, since all elements of row 2 divisible by 5, so that's why we divide this one. Row 2 tends to minus 1 by 5, row 2. So it will be what? 0, 1, 1, 1. Next, row 3 remains same. Row 4 remains same. Now, by using this one, we can easily make this in minus 11 equal to 0. Okay, so how we can make this one equal to 0? See here, row 3 tends to row 3 plus Row 3 tends to row 3 plus 11 row 2. 11 row 2. So row 1 remains same. Row 2 also remains same. So 11 row 2. So minus 11 plus 11. So it will be 0. Again minus 5 plus 11. It will be 6. Again minus 5 plus 11. It will be what? 6. Clear? Next, we can make row 3 divide by 1 by 6 row 3. So it will be what becomes 0, 0, 1, 1. Okay. Now tell me, is it possible to make these two elements equal to 0? It is not possible. Okay. So we cannot make these two elements equal to 0 by using any other row. You can say this one also, we can make this one equal to 0 by using this one. Okay, but then what happened? This element again non-zero. Okay, so what happened? We cannot make this element equal to 0 without making these elements non-zero. Okay, so therefore now see here, it is in the triangular form. Here the first matrix is the A, that means 1 2 1 0 1 1 0 0 1 0 0 0. At first look at this matrix, first matrix. See here, how many non-zero rows are there? 3 non-zero rows are there. So rank of A is 3. And this whole matrix is what? The augmented matrix, which is C. Now how many non-zeros are there? This is also equal to 3. So both rank of C equal to rank of A equal to what? 3. That means the rank of the matrix and the rank of the coefficient matrix and the rank of the augmented matrix is same. That's why this system is consistent. Consistent means what? It has a solution. Clear? Hence, this system is consistent and possess a unique solution. Okay, unique solution. Why it has a unique solution? Because the rank is equal to the number of unknowns. Here, how many unknowns are there? 3 unknowns: x1, x2, x3. So this is equal to the number of unknowns. Okay, so that's why the system has a unique solution. Clear? Now see here, initially the system is Ax equal to B. So we reduce this A in that form. We reduce the matrix A to the form 1 2 1 0 1 1 0 0 1 0 0 0. So we put this one A here. 1 2 1 0 1 1 0 0 1 0 0 0. And this is x1, x2, x3 equal to B is there. Now see, we reduces the matrix in this form. So B is what? 2 1 1 0 2 1 1 0. Simply the matrix is in the form, see here, it is in the form Ax equal to B, where A is the matrix of the coefficient of x1, x2 and x3. B is the constraint. Now as a whole, we combining these two matrices A is to B, which is called the augmented matrix is as C, and we reduces the matrix, we reduces that matrix, augmented matrix, in that form. Clear? So in place of A, we can put this one. In place of A, we can put this one, and in place of B, we can put this one. See here. In place of A, we put 1 2 1 0 1 1 0 0 1 0 0 0. This is the this is the matrix with the variables, that means unknowns x1, x2, x3, and this is the matrix with the constraint 1 2 1 1 0. Clear? Now multiply this one. Now multiply this. Now multiply this. See here what you got. 1 into x1, this is x1, plus 2 into x2, 2x2, plus 1 into x3, which is equal to x3, equal to what? This 2. Okay, it is equal to 2. Again, we multiply what you got, 0 into x1, 0. 1 into x2, it is x2 plus 1 into x3, that means x3 equal to what? 1. Again, 0 into x1, 0, 0 into x2, 0, 1 into x3, x3, which is equal to what? 1. Okay. Now, from comparing what you got, x3 equal to 1. Now, if we put x3 equal to 1 in equation number 2, what you got then? x2 is 1, 1 will be cancelled, x2 is equal to 0. Now, put x2 equal to 0 and x3 equal to 1 in equation number 1, we will get x1 is equal to 1. So, what is the solution? That means x1 is equal to 1, x2 is equal to 0, and x3 is equal to 1. So this is the solution. Okay. So in this way we can check the consistency of a system of equation, as well as we can find the solution also. Okay, when the system has a unique solution. Clear now? Is there any doubt? You can ask me. If is there any doubt, anyone? You can ask me if is there any doubt. Okay. So move towards the next. Now see here. Test for consistency and solve. Test for consistency and solve the equation. Clear? So here it is given how many equations are there? 3 equations are there. This is 5, 3, 7. So 5, 3, 7 is to what is the constant? It is equal to 4. Again 3, 26, 2. 3, 26, 2 is to 9. So this is 9. Again 7 to 10. This is 7 to 10 is to 5. Okay. So see here. So our aim is we have to make it in the triangular form. Okay. We have to make it to the triangular form, or you can say as echelon form. So here, that's why what happened, your aim is only you have to make this equal to 0. So you can divide this one by 5 and make it equal to 1. Clear? So R1 tends to 1 by 5 R1. So we divide the first row by 5. Then what you got? 5 by 5, 1, 3 by 5. It will be 7 by 5 is to 4 by 5. Okay. So next step, we have to make these elements equal to 0. 3 and 7 equal to 0. So how we can make this equal to 0? See here, row 2 tends to row 2 minus. Yeah, is there any question? What happened? Pinelo Dravid, is there any question? Rabbit. Pinelot, is there any problem? Is there any problem? Yeah, you can ask me. Okay, see here. So row 1 tends to 1 by 5 row 1. Again, row 2 tends to row 2 minus 3 row 1. Okay, so that 3 minus 3, it will becomes equal to 0. Clear? So again, row 3 tends to row 3 minus 7 row 1, so that this is 7 minus 7, it will becomes equal to 0. Same way we make these calculations also. Simply calculate this one, nothing else. Clear? So after this step, check whether we can make this equal to 0 by using this one. So we all know that 11 into 11, it is 121. So denominator is same here. So if we multiply row 3 by 11 and add with row 2, then this element becomes equal to what? 0. Okay. So that's why you can make divide by 11 also. Row 3 tends to row 3 plus 1 by 11 row 2. Okay. So after making this calculation, we got this is equal to 0, 0, 0. So after that, it is not possible to make this whole second row as a 0 row, because you can make this row equal to 0. There's no problem. But whenever you want to make these elements equal to 0 by using this row 1, these elements become non-zero. That means you will not get any 0 row. Clear? Now see here, this is simply the echelon form or triangular form. Now this is the matrix. The matrix left hand side of these two is the matrix A. So how many non-zero rows are there? 2 non-zero rows are there. So its rank is equal to 2. Since 2 non-zero rows are there, so its rank is equal to 2. And this is the whole augmented matrix. This is the whole augmented matrix C. So here how many non-zero rows are there? Here also how many non-zero rows? 2 non-zero rows are there. So rank of A and rank of C is equal to what? 2. So what happened? The system is consistent. But it is 2. How many unknowns are there? X, Y, and Z. 3 unknowns are there. 3 unknowns are there. That means rank of the matrix is less than to the rank of the matrix is less than to the number of unknowns. Okay. If the rank of the matrix is less than to the number of unknowns, then this system has what? Infinite number of solution. Clear? Then the system has infinite number of solution. Clear? Now hence here, hence the equations are consistent, but the rank is less than 3. That means the number of unknowns. So its solutions are infinite. Now see, same way we have to proceed. Ax equal to b. Same way we have to proceed. C. We make this matrix Ax equal to b. Ax equal to b. So after multiplying, what you got? 3 by 5x plus, 1 into x, it will be x plus 3 by 5 into y, 3 by 5y plus 7 by 5 into z, 7 by 5z equal to what? This is 4 by 5. Again, 0 into x, 0, 121 by 5 into y, that means 121 by 5y minus 11y by 5, 11 minus 11z by 5 equal to 33 by 5, and last one is all equal to 0. Okay, now see here in this equation, second equation, you can divide this one by, you can divide the whole equation by 11, then it will be 11y minus z equal to 3. After that, you can do calcium and you can cancel this 5 also. You can all this equation divide by 11 by 5, then you will got 11y minus z equal to 3. So you got 2 equations in 3 unknowns. See here, one is the first equation and the second one. So you got 2 equations. Yeah, this is after multiplying, after dividing this equation by 11 by 5, we got this one. You can check yourself. After dividing the second equation by 11 by 5, you will get this one. You check yourself right now, you can check, no problem. Clear? Now listen, you got how many equations? We got 2 equations. How many unknowns are there? 3 unknowns are there. So practically it is not possible to get a solution because we must have to get 3 equations in 3 unknowns. Then only we will get a solution. Okay, clear? So since there are 2 equations in 3 unknowns, and it has a, we already know that this system has an infinite number of solution. See how we have to proceed after this step. Okay, we suppose we consider z equal to k is a solution. We have to consider this one. We consider z equal to k is a solution. Then put z equal to k in the second equation. What you got? 11y minus k equal to 3. Now from here we have to find out y. So obviously then 11y equal to 3 plus k. So y equal to 3 by 11 plus k by 11. Again we consider z equal to k, and we got, when we considered z equal to k, we got y equal to this one. After that you have to put the value of y and z in first equation. That means x plus 3 by 5y plus 7 by 5z equal to 4 by 5. Here you have to put, see here, x plus 3 by 5 y means this one, plus 7 by 5 z means we consider k. So now see here, here is only unknowns is k and x, so we can write x in this one, minus 11, 16 by 11, you got this one. That means these are the solutions. These are the solutions where x is this one, y is this one, and z is equal to k. Now main thing is how you will get infinite number of solutions. Okay, so you will get infinite number of solutions by putting the value of k. By putting the value of k, you will get infinite number of solutions. Now let's see. If we put k equal to 1, listen to me carefully. Okay, if we put k equal to 1, then we got z equal to 1. Clear? Again, same way, if you put k equal to 1 here, then what you got? If you take LCM 11, so 3 plus 1, y equal to 4 by 11. Again, if you put k equal to 1 here, we can take LCM 11. In the numerator, it is minus 16 plus 7. So it will be minus 9 by 11. So if you k equal to 1, your set of solution is 1. It is 4 by 11 minus 9 by 11. 1, 4 by 11 minus 9 by 11. This is one set of solution. Similar way, you can put k equal to 2 also. Again, we can put infinite value of k, and you will get infinite solution of this system. Okay, so in this way we can check the consistency of a system of equation. In this way we can check the consistency of a system of equation, as well as we also can find out the solution of this system of equation. Your first one is what? First case is what? If rank of the matrix is not equal to the rank of the augmented matrix, then what happened? The system has no solution. That is your first one. That example I have already given. Second one is what? If the rank of the matrix is equal to the rank of the augmented matrix equal to the number of unknowns. Unknowns means what? Those x, y, z, or x1, x2, x3, that is. Then what happened? The system is consistent and it has a unique solution. Clear? That is the second one. And what is the third one? If the rank of the matrix is equal to the rank of the augmented matrix, but it is less than the number of unknowns. Okay, both rank of the matrix is equal to the rank of the augmented matrix, but it is less than the number of unknowns. Clear? Then what happened? It has infinite number of solutions. Okay. Okay, then that's all for today. Is there any doubt? Is there any doubt, anyone? Anyone, is there any doubt? Okay, then I will give some homework in the group. Okay, I will give some homework in the group and you have to try yourself. Clear? Okay, then that's all for today.